So, yeah, I want to start a little bit talking about what we are doing in Bochum regarding new technologies. So I want to talk a little bit about not only blockchain, also cyber physical systems, artificial intelligence, and of course also blockchain. And I think we can connect these technologies very good, and I will show how we try to do this and what other projects we are also do some research in. Okay, it's not working. Okay, sorry, it's not working. So now it's working. Okay, thank you very much. So I will start a little bit about my. So let's click here and now about my home university. So we are located in Berlin. It's in the east part of Germany. You see Berlin there, and Bochum actually is in the west part. So for us in Germany, it's far away because it takes 3.5 hours by train. I know from other participants, maybe the connection, you think, oh, it's nearby, it's a neighborhood of Berlin. So in this area, we have a lot of universities and bigger towns. Bochum is one of the smallest towns here, so maybe more famous is Cologne, Düsseldorf, or for soccer, Dortmund. So we are more or less in the middle. However, we are one of the biggest universities in Germany. So we have around about 42,000 students and also more than 6,000 international students, mainly PhD students also. So we are more or less a campus university. So you see it a little bit below. So we are a little bit outside, and we were founded after the Second World War. So we were the first university in this area. This was more a coal mining area, where a lot of industries were located there. Now we change a little bit, of course, more or less do some science and some innovations in this area. So a short introduction about my team. So I'm at the Faculty of Civil and Environmental Engineering. So we are normally organized in so-called chairs. You can also say it's an institute. So we are the chair of computing and engineering. It's very general because we are not only doing research in civil engineering, of course, also in environmental engineering, but we have also some research in manufacturing. We had projects with shipbuilding companies and so on. So we have at the moment, I think 20, maybe 21 research assistant PhD students, I would call them also, and we are organized in 3 main groups. So it's data management, artificial intelligence, and sensors and visualization. And we have also some quite nice equipment. So very often we use our Boston Dynamics bots to maybe collect some data, and then we analyze this later afterwards. But today I don't want to talk about all the research we are doing in this group. So I will concentrate on 2 or 3 topics. So one main topic we are just investigating is a little bit the production flow of precast elements. So of course this is you say, okay, maybe this solved. However, we are thinking about maybe we can create some kind of cyber physical system here with a digital twin behind it. And I will also show you a little bit how we integrate maybe IoT and also blockchain technology. So we are just starting with that into this whole system. So the idea is a little bit to have a very controlled production workflow, and we have a very big group there. So it's, I think in total 25 PhD students do research, and at different universities we are organizing this so-called framework program a little bit for our National Science Foundation. And so we work together with material science, with production systems and so on. And we are more responsible for the digital model or the digital twin to control everything. So the idea is also to create new modules, so new structures, how we can build like you know, Lego. So really to say, okay, how we can build based on a Lego system, maybe a bridge, and how we can replace some components. So not doing in situ concrete, more precast elements. So I think, so we can also learn, of course, from other countries here. So of course, as you can see, it's a complete production process also with assembly and maybe also measuring the condition of the elements further on. So what we apply here is a very special concept from Industry 4.0. It's called the so-called asset administration shell. So this is a standardized representation of an asset of a digital twin. So it's coming from the manufacturing industry, mainly from Germany. And so the idea is that for every asset, you build a shell around it. So with information and models and submodels, you can easily add a model, maybe have some communication. So, and you can dynamically update every asset administration shell. So if you have further information, it's not like a fixed digital twin, it's a modular digital twin. So we are applying this technology here, and very important is also, maybe that's why I'm coming also then to blockchain, is that every component has its own digital twin and has a communication layer where it can communicate between different digital twins. It can be in a digital twin of maybe a column communicating with another column. It can be communicating with a sensor, or maybe also with a robot or something like this. So it's mainly based on linked data concepts. A lot of ontologies are used, and we have very good standardized protocols for doing this. And there's also an open source implementation which you can easily download and create digital twins. So we applied this for in our field. So of course we thought, okay, we have a BIM model, something like this, where we have more or less everything in one file. Of course, this is also the data structure. And so for the production, we separate all the elements, and for every element we are producing, we are creating a digital twin. So an so-called asset administration shell for every element. And then we always use this digital twin for maybe quality control or whatever. So this is a little bit the idea, and we developed some concepts to integrate also the BIM model and also IoT data into this asset administration shell. So here this example is the quality control, where we have also some kind of AR, augmented reality features to support maybe the inspection of a just produced element here. So of course the nice thing is then that you can really combine all these digital twins together to a larger structure. So it's not a digital twin about the complete building. So we are collecting digital twins of single components, maybe also single installations, and they build maybe a virtual digital twin. And of course, then you can also decentralize the storage of this digital twin. So, and here, of course, we are thinking about how we created there. We are working on that at the moment, how we can create an overall platform to look up which digital twins are available, how they can communicate, and how we can maybe integrate further data here. So as you can see on the lower part, we have not only for the modules, we have for the whole structure, then also a separate digital twin. This is more this linking model, but you can also integrate a sensor and a machine. So the good thing here is really we have these standardized protocols and also data formats, and it's really easy to integrate new information into these models. So of course, what we can do with distributed ledger technologies, maybe blockchain. So we are just testing out. There's a nice paper about, not from our group, also how we can integrate these technologies to store the digital twins in a distributed way. So it's a little bit like you have a digital twin, so this asset administration shell, and you want to look it up. And how to look it up, you can use maybe the blockchain technology. So you store the information in the blockchain, or maybe they use in this field Tangle, that's a more network-based distributed ledger technology. And of course, also the information that is an update and something like this, all the transactions that you create in a new asset administration shell, you update something, all these transactions you store in the blockchain and you just look it up. And then of course, to load the real digital twin, you need only a link in URL. So, and then you download maybe the digital twin for your purpose and do some kind of simulation or analysis. So it's quite interesting. So we just starting with integrating this into our concept also for digital twins in construction. So another topic is, of course, it's very huge topic everywhere. It's of course artificial intelligence. So, so we have also a big project funded by the ministry here. Also, I think we are also bringing some demonstration later on in this room when we finish, we will finish the project next year. And it's about generating as-built models based on documents, point clouds, drawing images, and so on. I don't want to explain this in detail. So but what is the idea? So we need a lot of AI services. So we have now in total 65 AI services for creating parts of the digital twin for houses, office buildings, and mainly and bridges. So sometimes you need really some kind of a sequence that you create first, or you extract first the information from an image, then from a drawing, then combine this, then extracting something maybe from a document, and you have all this information then in the end, and then you generate based on that the digital twin. So as you can see, so it's not really good to read, but you see you have a lot of services, and every service produces some kind of data. So how we can organize this, and therefore we have in Europe a very interesting concept for so-called open data ecosystems. It's called Gaia-X. So that means we want to have a distributed, more open and more transparent ecosystem, that we are not depending on Microsoft or other big cloud services, that we have smaller clouds where we can connect the data a little bit. So a lot of countries in Europe joined this so-called Gaia-X project, and we have also South Korea and Japan, and I know also we are now working with US together. They also try to integrate this concept. So what is the main idea? Of course, to give the user really the full control about the data. So what does it mean in reality? So it's about data exchange. So when we exchange data from one participant to the other participant, maybe a data provider and a data consumer, so we need a data contract. So that we say, you use my data for a certain purpose, but only for this and only once. Or you have access for a week, or only for 20 years, or something like this. And of course, here we are using a smart contract based on a blockchain technology. So that means we need some kind of trust service where you find something like authorization, and that you are allowed to access the data. Then we have a logging service that logs the transaction and store it into the blockchain. And of course, we have to build a data contract service where you can have a contract between someone who provides data and consumes data. So it's a really complex architecture. So there is a so-called reference implementation, open source. You can just download and use it. However, of course, it's not that easy. It's not really a software what you just can buy. It's more or less a concept where we want to create some kind of ecosystem. So, and we also create an ecosystem based on this concept for our AI services here. So what is the idea? So we used an existing, we call this a catalog. It's like a portal or marketplace where you can just deploy some of your AI services. Say, okay, I'm the provider of a service or data, and you can buy this service. And therefore, we need some kind of so-called self-description. In this self-description, everything is written what you need as hardware requirements, which kind of data you can process and so on. And also this one, you see there's a wallet connected. So this everything is maybe based on there's a so-called ocean protocol. It's also blockchain-based protocol with ocean tokens and everything. And we have also some kind of payment in this system that you say, okay, this service is nice. I integrated this service maybe via an API into my existing environment, and I pay by use, or you have other concepts how you can pay it. So we are just creating this marketplace and all the things around here. So this is a little bit the idea for that. It's very essential that you not only can access one single service, because maybe you analyze an image and you get out maybe on this image is some kind of a column or a window or something like this. Or like here we have some drawings where we can extract some kind of elements for 3D models. Sometimes you have a chain of services, and therefore we developed at our share a so-called composer. It was also in a project funded by this ministry here. We have some kind of prototypes here. It's called BIM Swarm. It's like swarm services. And we're now using the composer in the new project as well for AI services, that we just connect services, and the composer is checking if the connection is correct, if the input and output matches, and how we can execute this. And then we set up a so-called message-oriented system. So because the service is always running on different computers, and then they're sending messages around, okay, I'm ready, I'm providing the data, and then you can access the data for the next service and so on. So this is also what we are doing. And of course, the transactions we are storing in a blockchain. So two applications where we combine several technologies here. So about cyber physical systems, so more or less IoT, you're collecting some kind of data, have some interactions. Of course, you are doing artificial intelligence, and sometimes it's really necessary maybe to store these transactions in a secure way, in a distributed way. So therefore, for me, always blockchain, you have to think about when really you need a blockchain. So if you have the need for distributed data storage, and you are not sure who is participating, then maybe it's good to store it in a blockchain. Or it must be very secure that you say, okay, nobody can maybe change the transaction. It's always very important. Then, of course, also blockchain. Sometimes if you only need a database, maybe blockchain is a little bit too much. So for me, it's always like, what is the problem, what we want to solve, and really sometimes blockchain is a good technology to do this. And I think especially for open ecosystems here, so where a lot of people working together in a digital way, I think we need something like this. And we also published a paper about smart contracts where we can apply them. I think there are a lot of possibilities still. So thank you very much. And yeah, if you have some question, of course, I'm happy to answer them. Thank you. So and now we have to maybe questions from the audience, or maybe we have some kind of question, or we do this after. I think we can do this now, right? Yeah. So if there's any question from the online participants, I think we can also hear them. I'm not sure. Maybe just turn on your microphone. or just send me a chat message. No, maybe some question here. Wisdom.
Yeah, I have a question. So thank you, Markus. A lot of interesting blockchain and cyber physical system applications. Really quite some new ideas to me. But particularly, I have two that I'm particularly interested in. The first one is a distribute digital twin. So very often we use a digital twin as a centralized information hub for the like a single source of truth. Yeah. But now we are thinking to distribute the information to different places, different blocks. So what kind of rationale behind this initiative? Yes, that's the first question.
So I think it's always of course, it's much easier to store something central. That's, however, then you need the access to all the data, and especially if you're thinking about a building or infrastructure, maybe some of this information belongs to the material supplier or to the construction company, and especially if you're thinking about the whole life cycle. And maybe you're collecting data maintenance. I think there is really a need that everybody can have their own data source and provide some of the data for certain applications. And therefore, of course, there must be always a link. So I need maybe further information about a product, and I can say, okay, you give me all the information during the handover, then maybe you have to store it. But if there are some updates or something like this, you maybe then just contact the material supplier. But it would be nice then to have a link to the supplier and say, okay, directly for that purpose, I get really the information. So I think this is really for operation. It's quite necessary that you have more or less a network. And I think that's what also the manufacturing industry or the automotive industry also doing. They say, okay, I have some data, maybe of a supplier of a certain product for the car, and we connect them only on demand. So, and of course, therefore, we have to store it. Something. So blockchain is also where you say, okay, I have a central way to access it, but of course we are not storing the data. It's always like there is the ID, a link to something, and then you can maybe download it. However, you have to guarantee that the data is always available. That's also a challenge. Yeah. Yeah.
Really, I respond a little bit. That really answered my question, because I have a student. His proposition is to also allocate the data through blockchain. But his proposition is you have a decentralized database in a blockchain, and then the machine learning can be more local responsive. Yeah. I actually doubt that. But you say that when you have a different supply of materials, and then to provide the information on demand, that actually can indeed increase the responsive speed. Yeah. I think.
So for example, in Germany we have a lot of regulations in Germany. So one regulation is about construction products. You have to check, as an architect or responsible to build a house, you have to check if this product is valid and it can be used in Germany. So based on our standards. What they do at the moment, they get the material on the site, and I'm checking this a little bit, and sometimes the material is not the correct material. It looks very similar to the one you ordered, but it's not the correct one. What they want to do, of course, to check it, and you get always the information only from the manufacturer or provider of this material, and they want to do it online. Say, okay, I check it, I will look it up. And then I get the certificate. Okay, it's valid in this state. It's in Germany. It's sometimes not in every state. Every material is valid. You cannot use it in every state, but something like this. And then you always have to have a connection to someone who provides you the data for a certain request. check.
Hey, hello, Markus. Yeah, thanks for your nice presentation and very interesting concept. So, you talk about dual twin, and you probably know that we also work on dual twin for the entire Hong Kong University campus. And I would like to seek your advice on some practical application of the dual twin. You talk about, yeah, those are the very forward-looking concept. But what we have encountered is that, for example, for dual twin, because dual twin needs to reflect the actual situation, and then but the actual situation keeps changing, and then how can we make sure that the dual twin itself will be kept updated? Particularly, for example, the dual twin will also need to link with other information, other data, but sometimes the links probably will be outdated. Yep. How can we make sure that it will not be that link, etc.? So particularly, who do you think should be responsible on the updating of the dual twin, or make sure that it's kept updated, and then how to motivate them to do so?
Yeah, very good question. So of course, if you have a linked data structure, then always the links are the difficult part, because so if you change here something, maybe it's not anymore fitting to the other side. Of course, I think we have at the moment we have also the problem. Maybe you get normal, conventional, maybe updates via email or documents. It's the same. Someone has to take care about it, and maybe if it's correct or not, and you have to update. However, I think if you have a good structure, we can check if where is the modification, is there a new version, and maybe we can define some kind of checking rules, which we also know from BIM, where we say, okay, we have a quality check and a coordination check and something like this, that we have rules just to check if the data is updated and what are the consequences, and maybe you have to check the other data source or maybe request a new update. I think we can manage this a little bit in this way, that we just say checking, and then of course we have to say, okay, maybe this data is outdated. So that's the way. Then of course we have to deal with that, but we need the information about it. So that's important. Of course, who's responsible? Oh yeah, there's always a question. So I think if you are thinking a little bit about automotive industry, of course you have one big company, and you get a lot of parts from different companies. Maybe from Bosch, you get some control elements for the car. And of course, there is some kind of agreement that you always update this information. So we need a strong relationship between the suppliers and the building owners and the construction companies. Maybe you have also some kind of contracts for that there is a need. So maybe, and then they pay also for this information. So I think we need also new business concepts, business models for that. It's not solved. We are still at the beginning. You know this also. So we have no digital twin of our city, no, of our campus or something like. So it's really new for everyone. But we have to think about also new business concepts, models. Thank you very much. And then, Abel, I hand over.